Welcome to this session of the Tallan Tech Talks. We're going to have Nicholas Galazza talking here tonight about SQL Server AlwaysOn. I think one of the things that any business owner wants to know is what's going to happen when the worst possible nightmare happens to them, and what will my business continue to exist or not? I think Nicholas might have one answer for us here, so take it away, Nick.
Thanks, Terry. All right, so like Terry said, we're going to talk about SQL Server AlwaysOn. And what AlwaysOn is it's two high availability and disaster recovery solutions featured in SQL Server. It was originally introduced in SQL Server 2012, but it continues to grow in importance in 2014. And much of what we talk about, if probably all of what we talk about here today, will apply to both versions. So like I said, two solutions. So we have availability groups and failover cluster instances. So availability groups give you high availability at the database level, and failover cluster instances at the SQL Server instance level. And we'll touch on both of those. Before we jump into it, though, we have to talk about WSFC, or Windows Server Failover Clusters. WSFC is a big topic unto itself, really, but we're going to touch on it because it's a requirement for both availability groups and failover cluster instances. So the Microsoft sort of definition here of a WSFC is a group of independent servers that work together to increase the availability of applications and services. What that really means is we have a cluster of Windows services. So when I say WSFC, or Windows Server Failover Cluster, just think of a cluster of Windows services. Two terms that'll come up are cluster resource and quorum configuration. A cluster resource is a physical or logical entity that can be owned by a node in the Windows Server Failover Cluster, and both AlwaysOn availability groups and failover cluster instances register components as cluster resources. A quorum configuration is the next term, and that determines the number of node failures that a cluster can sustain. Okay, so when we talk about quorum configurations, we're talking about what are the configurations, how many votes, what type of votes, who gets a vote, all these things that are involved when determining the health of the cluster or when the cluster should stay up. So a node majority is the simplest and most common configuration, and that happens simply when a majority of the nodes are active. You can also have file share majority, and a disk majority as well, and that happens when you have a remote file share or a remote disk, in the cluster that also gets a vote. And generally you see this in scenarios where you have an odd number of servers in the cluster, and the file share or the disk, that they kind of serve as the tiebreaker. So first we're going to touch on availability groups and how it relates to database mirroring. So database mirroring, like most of you I'm sure know, is kind of the old school way to do this, right? You had two servers and two SQL Server instances on those respective servers, and just like it sounds, you mirrored it. You redid every insert, update, delete onto the second server. Availability groups give you a lot more. We're going to talk about just how. So side-by-side comparison. The good news first is that you get more replicas, right? So instead of just a single database mirror, you have more replicas, you have more redundancy, which in turn allows for more failover. So we don't just have a single database we could fail over to, we have multiple. And we have mixed synchronous and asynchronous connections. I'll talk about that in a second. But we have options as opposed to database mirroring, which is just a one-to-one kind of thing. The last kind of cool feature that AlwaysOn gives you are read-only replicas. So we can have our secondary databases that we could use for reporting or as part of another ETL process. They don't have to just sit there on standby waiting for bad news, essentially. The downside of AlwaysOn is that it does require a Windows Server failover cluster. So it does make it a little bit more complicated. There's a little bit more in terms of moving parts. So when we talk about availability groups, there's a lot of terms and definitions. So I just want to throw a couple of those at you. So in case you see them or in case you hear them, you kind of know what we're talking about. So an availability group in and of itself is just a container for a set of databases called availability databases that can fail over together. Simple as that. An availability database, like, it's just a database that belongs to an availability group. A primary database is the single read-write copy for that availability database in that availability group. The secondary databases are the read-only copies in that group. So one primary, multiple secondaries. Availability replica, that's a term that you'll see in MSDN or other documentations, and those refer to the components inside the availability group. And each availability replica hosts a copy of the availability database. And the availability replicas are hosted on separate instances of SQL Server. And I know that's a lot in terms of definitions, but I think this diagram ties it together pretty nicely. So on the outside here, we have our Windows Server failover cluster. Then we have our respective nodes inside the cluster. The nodes host their own instance of SQL Server, and every instance of SQL Server has our database in question, right? Our availability database and our availability replicas. The availability group, however, spans all the nodes, right? It spans all the nodes in the Windows Server failover cluster. So hopefully that puts it in perspective a little bit. Failover and commit modes. So when we talk about availability groups, the first thing we need to talk about is commit modes, right? So we can have a synchronous commit or an asynchronous commit. And the synchronous commit, just like it sounds, is before committing transactions, the primary replica waits for the secondary replica to acknowledge that it has finished hardening the log, okay? So that you know that the data between the two databases is in sync. There's no data loss there. The asynchronous commit mode is the fire and forget, if you will. The primary replica doesn't wait. So the data may not necessarily have gotten there, and which option you choose depends on whether or not you're favoring data protection of the data or performance, right? Then we have a couple of failover options, right? So an automatic failover happens. When automatically, just like it sounds. The planned manual failover, this is a failover that's initiated by a DBA, generally for administrative purposes like an upgrade or something like that. And again, there's no data loss in a planned manual failover. We'll compare them all in the next slide. But the automatic failover and the planned manual failover, there's no data loss. The forced manual failover is the true disaster recovery scenario, right? This is when you're failing over to a database that's not synchronized, that's not in a synchronized state. So you don't know if it has all the data that was on your primary replica. So this next slide here kind of brings it all together. The automatic failover is supported only when the current primary replica and the secondary replica are both configured in an automatic mode and they're both synchronized, right? So that's the state they're in and they're both set for automatic. The planned manual failover is supported only if both the primary replica and the secondary replica are configured for synchronous commit mode. So you're not set for automatic. They don't have to be set for automatic, but they do both have to be synchronized in order to do a planned manual failover. A forced manual failover essentially has none of these requirements. It can happen, the DBA can sort of flip the switch whenever they want, but it's the only option available when you do an asynchronous commit mode. Okay, so again, this is the true disaster recovery option. This slide is kind of an extension on the last slide with synchronous commits and asynchronous commits and all your options included. Okay, so it's the same as before. We have we have our Windows Server failover cluster, we have the respective nodes and SQL Server instances, and we have the availability group. But this time we have a primary and a secondary with synchronous commit mode and automatic failover. So this would be the first thing to happen. If the primary were to go, it would automatically fail over to the secondary replica. Then we have the next secondary replica here in blue, which is again synchronous commit mode. So we know that there's no data loss, and the DBA can throw the switch safely, and we can move to that replica. The last two are asynchronous commits, right? So we know that there's a possibility of data loss with those two, and our only option for failover is a forced manual failover. Okay, so those are our last resort. We'd rather not go there if we could avoid it. Next, we're going to talk about availability group listeners. So an availability group listener is a virtual network name to which clients can connect to in order to access a database in a primary or secondary replica of an always-on availability group. Okay, so the client uses the DNS to resolve the virtual network name into multiple IP addresses, and then it tries to connect to each address until a connection request succeeds or a connection times out. So essentially, this is the abstraction layer for the client. Okay, so the client can connect to the availability group listener, and it doesn't have to know anything about the availability group or the subsequent SQL servers involved in that group. Here's a connection string too in this slide. You could put that right in your web config, and it doesn't have to be modified in the case of a failover or anything like that. The final thing that's cool about availability group listeners is if you notice at the end of the connection string, there's that application intent equals read-only. And what this will do is this will cause read-only requests to be routed to the secondary databases. So it's smart enough to know that if it's not a transactional sort of request, you won't bog down your primary database. So you could use it for reporting or just part of a larger ETL process for backups, anything like that. And so your secondary replica doesn't have to just sit there idle. As far as setting up an availability group, it's very simple. It's kind of two parts. The first part is the SQL Server, to go into SQL Server Configuration Manager and make sure it's enabled. And as you can see, right click on it, go to Always On, and just make sure the checkbox is checked. That's pretty much all there is to it. Once you do that, inside of Management Studio, you could navigate to the Always On High Availability folder, and if you right click there and you click Add an Availability Group, there's a simple wizard, maybe 5 or 6 screens. I won't bore you with all the screens, but this one in particular, this is kind of the meat and potatoes of the setup. This is the screen where you would add replicas, determine what type of failover you're using, what type of commit you're using, whether or not the secondaries are readable. Very, very simple to set up. Always on failover clusters. Okay, so we were just talking about availability groups, and this is a failover cluster instance. And so again, a failover cluster instance is high availability at the SQL Server instance level as opposed to the database level. FCI is a single instance of SQL Server that is installed across a Windows Server failover cluster node. An FCI can be a single instance of SQL Server across multiple subnets as well, if you're so inclined. And on the network, an FCI appears to be an instance of SQL Server running on a single computer, but the FCI provides failover from one Windows Server failover cluster node to another if the current node becomes unavailable. And so what's cool about this diagram is it shows how you can use both at the same time and how they differ, right? So again, on the outside, we have our Windows Server failover cluster. Then we have our respective nodes in the cluster. But notice that the last one is different. We have a SQL Server instance that spans 2 nodes and a secondary replica that sits inside that SQL Server instance. But again, the availability group spans every node in the cluster, okay? And it sees that failover cluster instance as a single SQL Server instance. Another difference here is if you see the little storage bubble below it, a failover cluster instance does require storage that's available to both nodes in the cluster, and generally that's done via a SAN or some kind of external storage like that, which would be registered as a cluster resource. And if we were to continue to compare them, again, I know I keep hammering home this point. If you take away nothing else, just remember that an availability group is high availability at the database level, and a failover cluster instance is high availability at the SQL Server instance level. So that includes more than just the database. Secondary nodes in an availability group can be read-only, a good solution for reporting. Secondary nodes can't, right? So they're just inactive and they wait for failover. An availability group requires an availability group listener for abstracted client communication. The failover cluster instance, the virtual network name, will take care of directing traffic to the active node. And then storage, like we just mentioned, availability groups don't have storage requirements. The failover cluster instance does. Okay, so that's when you would have your SAN that's viewable over the network by both nodes in the cluster. So my last couple slides here I want to show you how people are using AlwaysOn, specifically availability groups. What are some of the configurations and how do all these pieces fit together? Okay, so here, as you can see, we have a primary data center and a secondary data center. And notice the vote assignment, right? The secondary data center doesn't have a vote in the quorum in the Windows Server failover cluster. And the reason for this is if there's some kind of outage or downage in your DR site, you don't want it to affect what's going on in your primary data center. Okay. They added an additional node here in the primary data center, and the reason for this is so that we can have a node majority. So the SQL Server, the box with the SQL Server, the node with the SQL Server doesn't have a vote, and they made up for it elsewhere in the primary data center. Again, to try and get that nice majority, that nice quorum majority configuration. We also have a synchronous commit and most likely an automatic failover between the two SQL servers in the primary data center. And then we have an asynchronous commit mode with that SQL server in the DR site. And again, that would have to be a forced manual failover. That would be your disaster recovery. That would be your true DR scenario. And if you did that failover, if you had to go through that failover, there's a possibility for data loss. Okay, this slide is very, very similar to the last one. Just wanted to emphasize here that instead of a disaster recovery or a colo or a DR data center, you could use Azure, right? So we're seeing this a lot too, where you have an automatic failover to a secondary in your local or your on-premise data center, but you have that asynchronous replication in Azure. This diagram is also cool because it shows the availability listener is here, and it shows you directing traffic. You know, your transactional traffic goes to the primary, and you can have read-only traffic go to a secondary. That's one of the really cool things about an availability group. Okay, this last slide here is yet another configuration. This time we have 3 data centers and a quorum vote in each of the data centers, right? So the primary reason for a solution like this is so that you can have an automatic failover between data centers. The third data center here is just acts as literally another vote for the quorum. But you have a synchronous commit here, and most likely an automatic failover between data centers, which is pretty cool. I know there's some talk that some of the older high availability solutions like mirroring and log shipping are going to be deprecated in some of the future versions. So Always On is here to stay, and it's a good time to learn about it and start thinking about how it can help you.
Ready for questions?
Sure.
Any questions out there?
Hey Nick, this is Reddy. So on that screen that you were showing where you were setting up the availability groups,
Yes, sir.
what are some of the guidelines to kind of group databases together? So what would make it into one group versus another group?
Into one availability group versus another group?
Yeah, so you can have multiple availability groups, right? Did I get
Sure.
that right?
Yeah, you could have multiple availability groups.
So how would you, like, say I have 15 databases I'm just talking about SharePoint. So I've got 15 databases in SharePoint. I want to create availability groups. Would I just create one availability group, or would I create multiple availability groups?
For the 15 separate databases, you mean?
Yeah. They kind of work. The reason I asked that is because some of those databases have data that goes across them, right? So it's not just monolithic databases, especially like in an application like SharePoint. So is there like a guideline to follow where you say, okay, the master database and the temporary database need to go into their own availability group, and the rest of the databases go into their own availability group? Any guidelines like that?
I don't know if there are any formal guidelines. Mostly from what I saw, it tends to be kind of a logical thing from the user or the DBA's perspective. It's sort of, okay, this is the availability group for, the database, these sorts of databases, databases related to application A or related to, A, and then these databases, okay, we'll group them together into this sort of, it's kind of a logical distinction.
Okay. Yeah, I mean, because a lot of companies, even if you don't take SharePoint perspective of it, but if you just consider multiple applications having multiple databases, right? So application A has a database, application B has a couple more databases that it's using, and so on and so forth. They have a single SQL Server environment that houses multiple databases. Would you kind of recommend that they create multiple availability groups from a best practices standpoint? Have you kind of come across such a installation?
I'm not sure. The other factor there too would be where the failover cluster nodes going to reside too. So are all the databases, if you're going to use Azure, are those databases are in Azure as well? Would they be in the same would they be in the same availability group? So yeah. That's another factor too.
Yeah. Okay.
Go ahead.
One other thing I was thinking is if you have different teams that are working on different applications, you might want different availability groups. I mean, if you are even just testing the failover, you don't want to impact other teams potentially. That might be another scenario.
Yeah, that's a good point.
But I think, Reddy, for your example, if all those SharePoint databases go together, I think I'd rather have those as one group.
One group, okay. And why would you choose like asynchronous versus synchronous?
I don't think generally. Sorry.
Here's something I would add about that. In one diagram, you mentioned you had synchronous commits across data centers. Mm-hmm. And my understanding is that's not recommended because performance going across disparate, networks like that would basically increase locking on your primary because it's still waiting for the secondary to commit. My understanding is that synchronous you want when you want no data loss, like you mentioned, but that they're also close by in terms of network performance. So like within the same data center, the same subnet or something. That async is more for going across to remote data centers or going into Azure, because you don't want to increase locking, because the time has to wait for the commits to come back.
Locking and just the response time too.
So Andy, or Nick or anybody else, if you were doing like an asynchronous commit, right, onto Azure, that's going to take a while, right, from say on-prem to on Azure. Is that like the scenario that you would kind of go for if you're talking about disaster recovery instead of just backup restore?
I think it was the other way around.
Or availability.
I think it was the other way around, wasn't it? If you want complete recovery and no data loss, you want it synchronous, and it has to be in the same on as short a wire as possible. Basically, I think that's what I heard here.
Right.
And
I think it's like if you're doing disaster recovery, you have to assume, even with database backups and log shipping, you might lose a minute, a few minutes of data, a few seconds, but that's okay for a disaster recovery situation.
Right.
But if we're talking about local failovers, you don't want to lose any data, so therefore you want to have synchronous commits, but keep the asynchronous for long distance failovers.
Okay.
And just a couple other things I would add. Number one, in terms of the replicas, actually in 2014 it increased it. You can have 8 replicas, but in terms of synchronous commits, I think you could only have like two additional secondaries. And then in terms of the quorums, I know you mentioned you want to use the file share or disk quorum when there's odd number of servers, but I think it's actually the opposite. It's only when you have even that you need to introduce an additional
yes, even.
one.
You're right. Yep.
Vote.
yeah, it adds it adds 4 secondaries in 2014.
Say again?
It does add 4. It's up to 8 secondaries, and they're saying that this additional secondary replicas can be used to distribute read workloads.
So Nick and Jared and Andy, I guess, what from my practice standpoint, what would be nice to have is kind of guidelines to use availability groups for SharePoint installation. So we right now, the practice folks generally do the whole installation from SharePoint front ends, app servers, all the way to the back end servers, and we usually just do, when we're talking about clustering, we just do active passive, which is the old way of doing stuff, right? With 12 or even 14, we can use the availability groups, but we've tried to stay away from it. I think there's just one installation where we did availability groups, and that's because Garrity was there on that project, and he did it. But generally, we don't have any kind of, expertise on the practice to do kind of the installations for availability groups and all that goes into it in terms of, how many servers do you need, and all that capacity planning and all that stuff. So is that something that, Jared, you could help us out with?
I think it would probably make sense to do that. I mean, if we are, doing a significant number of installations, it probably makes sense to at least propose that as an option, let them decide. I think the DR piece might be a separate conversation. Usually the whole DR thing is a separate even endeavor from a project perspective, but I don't think the setting up the availability group should be that significant of an undertaking. As far as it having access to both, I'm trying to think and I mean I'm not sure exactly how SharePoint's connecting to the database, but I mean obviously all the writes are going to go against the primary, but if there is something like maybe findability, for instance, that could go against the secondary with read intent, that might help from a load perspective too.
Right. And
That's what I was just thinking was, if you're dealing with SharePoint, how critical is that to running the operation? And it seems to me that it's mostly read and not a lot of write, and therefore, you'd go the asynchronous route with as many servers available to you as you could.
Right.
With read intent.
And is that automatic, like the read intent versus read write, or does that go into the connection string? I know, Nick, you were mentioning connection string with like the intent piece in the connection string.
Yeah,
is that necessary to put in there, or is that like taken care of based on what the application is doing?
I believe it has to be in the connection string for the listener, the availability group listener, but I'm not 100% sure.
No, that's true. It has to be in the connection string, and that means that basically, if you have an application that does both, it can't use that feature. But if you have like a application that does only reporting, then you can use that feature, right? Because otherwise, how's it going to know from one, call to another whether they're
exactly. Yeah.
Well, and the reason I mentioned findability, like for MassLedge, for instance, we had an application. The public site application was mostly read. It did do occasional writes, so we actually had 2 different connections set up in our web config, and most of the time we would use the read. So it is possible to leverage both from a single application. SharePoint, obviously, a little different animal,
right,
as far as creating connections are concerned, but I'm sure Mike could figure it out, right?
Yeah.
The other thing to keep in mind is, I think what's so important is that, the pros and cons of the groups versus the failover cluster, right? So, the failover cluster requires more work, more, requirements. You have to have shared storage. You have to, set all that stuff up in the Windows cluster, and then, you have to do a different setup in terms of how you install SQL Server. But it does give you instance level failover. So, your SQL agent jobs, everything is, your security logins. With the, if it's just the availability groups and the database level, you get the database like high availability, but then you got to like manually replicate any server level changes to the other servers, whether it's logins, whether it's, agent jobs, other things like that.
That's a good point,
something else to keep in mind. And then when it comes to like BizTalk projects, BizTalk still does not support availability groups because it requires, MSDTC and shared storage for high availability. So right now you have to use failover clustering if you want BizTalk high availability, and that's also why BizTalk does not support high availability in Azure, because there's no such concept of shared storage in Azure. And so definitely I think from a BizTalk practice we kind of knew this was not an option, but for custom applications, and like for a CRM project we're doing, we found that it actually is an option.
Yeah.
Yeah. The one point you made, Andy, about the logins not replicating with the availability group, that is definitely something we ran into. We'd fail over, and then half the applications wouldn't work because certain service accounts just weren't set up in the other. So definitely something to consider.
Additional questions?
Yeah, I had one more question, something I'd never tried, but when I set it up, you have to pick which databases and add them to the availability group. Do you know, can you point to the listener and say, hey, I want to create a new database? Or do you have to create the database on a single node and then add it to all the other machines later? The only reason why I asked this is, like, for example, when you go through the CRM setup, I had to set it up on a single box, then make it availability group, and then go back to CRM and change all the connection strings to be the high availability, the listener, so that therefore, the failover is transparent to the application, which is a big advantage over like mirroring, for example, because that would, require a manual process. But do you know if let's say I did set up an availability group and I put like a placeholder instance, if I went through CRM, could I like put in that listener address and then CRM could then create a database and it would automatically be applied? Probably not, right?
I'm honestly not sure.
Yeah,
have to get back to you on
I would
that.
say probably not as well, but I don't know the answer, but it's worthwhile researching here. But we won't know it tonight, probably.
Yeah, I would agree that it's not likely the case. You probably have to create it first, or have CRM create it first, and then repoint it later.
Yeah, because the other thing I noticed was if it requires your databases to be in full recovery mode, and you have to do at least a single full backup before you can put them into the availability group. And I bet if the application was trying to create databases, it probably would just fail.
Yeah, one thing that we did, Andy, actually, is
right.
we originally had the database server, let's say it's like SQL 001. What we ended up doing is making SQL 001 eventually our availability node, DNS name. So we didn't change the connection string, we changed it on the back end after the fact.
Yeah, I figured that's got to be the process because they have a whole write-up on the steps that you have to do anyways, and it seems to follow the steps that we ended up doing. So I guess from Reddy, your perspective, it's almost like you'd have to configure SharePoint to point to a single node, then set up the availability group, and then reconfigure SharePoint to point to the listener, or do something like what Jared's team did, which is set up a listener with the same name as the primary node.
Okay. Did you use aliases there, Jared?
I don't know. That was totally Mike. So.
Oh, okay. Okay. Yeah, I just need more, a little bit more guidance on this stuff on AlwaysOn. It took me a while to just understand it first. Now that I understand it, I've never actually deployed it. But I want more of the practice people to be able to do this on their own.
Any further questions?
Good job, Nick.
Thanks.
Okay, great. Thanks, everybody, for coming out. Lenny will be up next. He'll be talking about SSDT, so look for an announcement in a couple of weeks as to Lenny giving his talk on SQL Server data tools. And with that, I think we're done for tonight, and I thank everybody for coming out.
Thanks, Terry.
Yeah, thanks, Nick. Thanks, Terry.